What's up guys, PJ here from 3D Printing Canada. So today what I'd like to talk to you guys about is our filaments, different filaments we carry, how to print them, maybe bed adhesion problems you might have, and just kind of go on about how to print these filaments. So without further ado, let's get into that first roll. Okay, so the first filament I'm going to discuss here is PLA. PLA is very basic and easy to print with for the most part. It's what you're going to start out with for sure. Now we've got a roll of, this is my favorite company to date right now for filament Spectrum. Their products are super accurate. Everything they carry that they've sent me to print has been absolutely wonderful. You pay a premium price, but you get a premium product, definitely with this. Now this one ranges from 190 to 230, so it's a little bit more of a premium PLA being to print up at a higher temperature. It should be extremely easy for you to print. If you're ever really having trouble with it, it's probably more than likely a bed leveling issue. So if you don't have an auto bed leveler where you can Z compensate or baby step while printing, what you can do is whatever the size of your bed is, whether it be, you know, like your ender size bed like the build plates I have here, or if it's your big, you know, 400 size bed, you can go ahead and get a bed print from Thingiverse for the size of your bed, and you could literally just start printing and adjust the bed knobs while you're printing. So that's another little trick. And a good trick for big parts that doesn't matter what material you're printing, might want to curl up in a corner or something. Glue stick, Elmer's washable glue stick. We carry it here at the shop just for that reason. I've had the most success with it. Some people will use hairspray. I don't recommend ever spraying your build plate while it's on the printer if you're going to use hairspray. As well as if you're going to use hairspray, you could get maybe the liquid stuff that comes in an air pump bottle instead of an aerosol. That's another option. There are other products on the market, but for the most part, I've been the most happy with glue stick. Again, PLA is really easy to print. For most people, this will be your beginner and intro. Actually, I brought up some build surfaces with me today, and any one of them PLA will stick on. So if you're using like a build tack, like a polycarbonate or something, you're gonna wanna clean with 99% isopropyl alcohol. If you're using, say, carbon fiber, if you're a little more advanced and you've purchased a piece of carbon fiber for your build plate, whether it's from us or another retailer, you're gonna wanna go ahead and use glue stick on this every time. Nothing's gonna stick to that glossy finish, but it's also super strong. Now for PLA, same with glass. Carbon fiber and glass, they're both gonna need glue stick unless you've got the silicone carbon or some type of build plate that's glass that's been designed to hold your prints down. And then again, last but not least, probably most people's favorite is the spring steel sheets. So, you know, you've got your magnet that goes down on your build plate, and you either have a smooth side of PEI or, like we have here, textured side to the PEI. No adhesive required. So PLA will pretty much work on all the build surfaces. Sometimes you just might need to use glue. So moving forward past the PLA, we're gonna move on to PETG. And this is where most people, so I've got a roll of PETG here again. Now I did bring up all the products I personally like, just from testing, constantly using filaments. I brought up the ones that I personally like the most. So I've got right in front of me, I do like the house brand stuff. The standard works really well too, especially for ease of printing. The standard house line works really good. So we've got just regular PETG in front of us, again from Spectrum. The cool part about it is you can track the actual diameter when this came off the line. So that's pretty nice. It's another thing I really like about them, their tolerances. The diameter of the filament is very accurate. And if you're well-rounded in 3D printing, you already know this. Okay, so with PETG, on this one it says 230 to 255. I found around 245 was my sweet spot for this one. Now, if it was, say, our standard line, you'd be looking at 230. I always use 70 on the build plate. For the most part, I find it works best. Now, personally, I've always used glue stick with PETG on glass, on carbon. Maybe we'll kind of leave these build surfaces out so I can explain why I use them. Now, the carbon I personally only use now, unless I have to use build tack. Now PETG, it'll work on the textured side here of this. It'll definitely work on the textured side. On the actual PEI side, you're probably gonna pull pieces of the PEI off. So if you only have this, make sure you apply some glue stick so you don't damage your PEI. Carbon fiber, obviously we're using glue stick, and I still use glue stick on the build tack for regular PETG. Now, one main problem most people have, PETG can be printed without the part cooling fan completely. You don't need it. You can go around 30% and then maybe for a big bridge have it do 100%, but you never want 100% fan with PETG. You will have layer adhesion problems. So you'll have to go into your slicer, whether you're using Cura, Simplify 3D, Prusa slicer or super slicer, you'll have to go into the advanced or expert options. Make sure you open those up, go into the fan section, and make sure you have that set to never above 30%. Personally, I don't, unless it's bridging. Other than that, PETG is pretty much like PLA in my opinion. Other than the fan speed and the temperatures will be a little bit different, it's still relatively really easy to print. Another nice thing is if you have PETG with carbon fiber chunk or powder in it, it stays really dimensionally stable. I love products with carbon fiber in them, so even PLA with carbon fiber, I like it too. It's just, it's a really good product to work with. So moving forward, I have one more PETG to show you guys, and this one's pretty neat. It's a high temperature PETG. This stuff prints from 250 to 280, so you would need the machine that could print it. I did print it actually at 290, I found was the best on the machine I used. And the kicker to this was it would only stick. I tried with everything you see on the table, even glass. The only thing it would stick to was the build tack. And I did have to clean it with alcohol to make sure it was clean. So keep that in mind. If you go with a high temperature PETG, it seems to me that the build tack is the only thing it sticks to. And yes, it's definitely trickier to print with. And of course, because of the high temperatures, you won't be using any part cooling fan unless you're already well-rounded and you're more advanced. Then of course you'll use part cooling fan even on ABS. So with that being said, just to keep things simple, no part cooling fan required at all for the high temperature PETGs. All right, next, let's talk about ASA. We'll kind of throw ABS into the mix here. Really cool product. It has its uses. It's not for everybody, definitely, due to the smell and the odor. It definitely has toxic fumes. Would not be printing this around children, animals, things like that, or yourself, to be honest. It all has ammonia in it, and it is toxic to breathe in. With that being said, you would definitely need a fully enclosed printer for this. And if you are pulling the toxins out, you need a way to keep the heat inside the chamber without disturbing the air too much. Reason being is ABS and ASA love to warp. They love to layer split. To be honest with you, they would love to have a heated chamber to keep everything evenly heated the whole way through. And then keeping them stuck to the bed can be pretty tricky as well. There's a few things like actually taking chopped up ABS, dissolving it in acetone. There's a mixture online, you can Google that, and then you actually spread that around on your glass or your carbon fiber. I would definitely recommend using carbon fiber and at least glue stick with ABS and an enclosed printer. So if you don't have an enclosed printer, I really don't recommend it. You might get some small parts. Anything big or anything like that's probably not going to work. You'll get to the point where the layers are just splitting apart and it's warping off the bed. So with that being said, ASA is a little bit easier to print. So I've got the Spectrum ASA with me here. It is a little bit easier than ABS, but again, it's still the same properties. It's still the same concept, just a little bit easier. This stuff here says it prints from 200 to 240. I've always found ABS, I've had some that'll go at 220, 230, 240. I've had a few that go a little higher. So, you know, things like this though, do temp towers. If you've never printed with something, you want to do small test prints. So anytime you're getting into a new filament, don't even think about that object you might have wanted to print that's huge. Start off with a small test print. Start with your cubes. You know, you can do hollow pyramids, temperature towers, etc. But keep in mind, this stuff is really tricky to print, and be ready for some failed prints, guys, because it's going to happen. What do we have next here to talk about? So let's talk about my personal favorite, TPU. It's easy to print with the right drive. What we've got here in front of us is some comparable to SainSmart. It's a little bit cheaper, and prints just like it. Love this stuff. It's all I use. When it comes to TPU, there's many different types of TPU. There's TPEs. There's companies calling stuff flex. There's flexible PETGs. There's flexible. They all kind of fall into the same category. Some just might not stick to build surfaces the same. Personally, that's why when I'm using a flexible product, I like to use TPU unless I need something ultra soft where I might need a TPE, which TPU and TPE are kind of one and the same. It's based from TPE to make TPU. It's the same material properties. So the one I have in front of me is a 95A. Definitely it'll be more flexible with less infill. The more infill, the more rigid it'll be, but still have that really strong. I personally use it for GoPro mounts on racing drones, so it definitely takes some punishment. One key thing, it will print on a Bowden tube with the right extruder very slow. So I recommend if you want to print TPU and have it print just as easy as PLA, you're going to want a direct drive extruder that has 0 space gaps. So just because it's direct drive doesn't mean it'll print TPU easily. My favorite is the Micro Swiss direct drive, as well as their new generation direct drive. Orbitals will do it. You just need to bear in mind where the gears push the filament, and dual gear is definitely a must in my opinion. Where the gears push the filament into the space that goes down to your hot end, you don't want there to be any gap where the flexible filament on a retraction could spit out the side, or inside an enclosed drive where potentially it could spit inside the gears and strip out some gears on you. So personally, I use the Micro Swiss direct drive myself for all my flexible 3D printing. And the nice thing about it is, it doesn't matter what surface you put it on, put some glue stick and it'll work wonderfully. No matter what I'm using, PEI, build tack, I just throw a little bit of glue stick on and it sticks wonderfully. Now I find the temperatures for TPU can vary. The stuff we have here in the shop, like our house brand, the comparable to SainSmart stuff, it's 215 to 220 on the nozzle and 60 on the bed, just like PLA with glue stick. 100% fan, that doesn't change, just like PLA. As well as your retractions can vary due to the direct drive. So on the Micro Swiss, I put my retractions at about 2. If I'm still getting stringing, I'll actually just lower my flow rate or extrusion multiplier. So that being said, guys, it's a little bit of tips and tricks on some TPU. What do we have next? One of my other favorites, so we'll save one of the best for last. I'm actually going to pull 2 filaments out here. It's nylon, so we've got some nylon here. We've got nylon, like a PA6, or the eSun nylon, like a bridge, I guess, nylon, and some nylon CF. Now, nylon, it's tricky. It's tricky like ABS, but maybe a little bit easier in my opinion. Now, build surfaces. Again, this could maybe be objective and just an opinion because other people might have something else they use. My personal favorite is carbon fiber, plain and simple. It doesn't break. You're not pulling chunks. Like I've broken many pieces of glass with nylon on big parts. So carbon fiber, I just don't even question it. Carbon fiber, glue stick, Some people use other adhesives for nylon. Go ahead, put that on your carbon, good to go. I don't even think about PEI. It's gonna rip chunks of the PEI out. It'll even start to pull up that painted, powder coated PEI from a textured side. And yeah, it could really adhere to the build tack pretty good and pull chunks of that out as well. So again, opinion, I always will use carbon fiber for nylon, just so I don't have to worry about it breaking the glass. You can use Garolite too, so like circuit board material, Garolite, you can use that as well. But I've still found my best results personally have been on carbon fiber. Nylon is another material that can print. It's gonna, most nylons, I would say 90% of them are gonna start at around 260, all the way up to 320 range for high temperature nylons, depending on what you're printing. For basic stuff, just getting into it, I could E-Sun nylon, or yeah, the E-Sun nylon is definitely the best bet by far. It's got a low warp factor to it because again, it's a polymer. It's gonna be difficult to print. You're gonna have a bit of a hard time with it at first. You're definitely gonna wanna slow down your printer until you learn it. I'd say start at about 30 millimeters a second and work your way up. Remember, small parts are gonna have to print slow because you're not using part cooling fan. If you use part cooling fan, your layers will not adhere and your nylon will just strip apart. Supports, they're a nightmare with nylon, but again, when you dial them and you spend the time to get the angles right for your supports and your extrusion multiplier, which is extremely important. Now, I think the easiest test for anybody to do with any material, whether it be PLA or it be nylon, TPU, whatever you're doing, what you can do is a simple hollow cube with one wall. And if you're using a 0.4 nozzle with a 0.4 width line, you want to make sure that when you take a pair of verniers or calipers and measure that wall, you want to make sure you're within 0.5. So you want to be, if you've got a 0.4 nozzle with a 0.4 width line, you want to make sure you're within that 0.45 to 0.4 range. Otherwise, you're over extruding, and then supports with nylon, they're going to be a nightmare to take out. Moving on to the nylon carbon fiber. So nylon's great. You can print frisbees with it. My kids have a blast with it. It hits the concrete. The ones we print are really cool. They have a leading edge. They take abuse. Nylon, impact resistant. Love it, love it. Nylon carbon fiber. Now, if it's only got 10% dust, it's still gonna have some flexibility to it, but add a bit of rigidity where it might snap easier. So it varies on the brand of carbon fiber nylon you're using. But the E-Sun stuff, it's probably just about 10% dust, so it's still got the flexibility a bit to it, but it's also really, really lightweight. Easier to print, I would say. You do need a hardened steel nozzle though. Any carbon fiber or wood-based material, you're gonna need a hardened steel nozzle, and I highly recommend 0.6 or 0.8, depending on the part. If you still need some detail, I would stick to a 0.6. If it's a circle or a jig for a CNC machine, go ahead and use a 0.8. It'll speed up the process. But both of these products, I find both of the E-Sun products printed at 260, 0 part cooling, of course, and I just use 70 on the bed. Again, if you have a heated chamber, things can change, because then if you had a 90 C bed temperature, you could match your chamber temperature. That's okay. When you don't have that, I find, for me anyway, 70 has been the best, because as the layers cool and the part wants to shrink, if you're at 90, the bottom is still soft and pliable and will start to pull up from the build plate. So I find 70 has been my happy medium for basically anything except for PLA and TPU. I've just been using 70 on the bed. Every time I've played with a bed temperature without a heated chamber, it warps off the bed. So keep in mind, if you want to get into nylon, one of the main things you're gonna, I can't recommend any higher as an enclosed printer. Whether your printer goes inside of one of the grow tents that Creality makes, or a hot box, or you build one out of extrusion with plexiglass, whatever it may be, get that enclosure around that printer, keeping the breeze and the temperature a lot more even inside your print. So with that being said, guys, That kind of wraps up my little explanation on filament here. I hope you liked the video. I hope I didn't ramble on too much for you, and we'll see you in the next one.